Imagine you are drifting in a boat in the middle of a calm ocean, but suddenly you notice that despite the complete stillness, your boat is being carried in one direction at immense speed. You can't see what lies behind the fog, but you feel the current getting stronger and stronger. This is exactly what is happening to Earth right now. Our planet, the Sun, and the entire Milky Way galaxy are being dragged by something so colossal that it's pulling millions of galaxies towards itself. But the scariest part is, we can't see it. Astronomers call this place the Great Attractor, and it is the most terrifying riddle of modern cosmology. What is hiding in the blind spot of the universe? A giant black hole? A glitch in the matrix? Or something for which we don't even have a name? The rules of the universe. To understand the full horror of the situation, we first need to remember how our universe is supposed to work according to the rules. Imagine a raisin bread baking in an oven. The dough rises, and every raisin moves away from all the others. This is exactly how the expansion of the universe works, discovered by Edwin Hubble almost a century ago. Space stretches and galaxies fly away from each other in all directions. This is a law. The farther a galaxy is from us, the faster it runs away. This is called the Hubble flow. If we follow this logic, there should be no chosen directions in space. We should observe objects moving away from us uniformly, and we ourselves should drift with the current of expansion without crashing into anyone. But in the 1970s, astronomers decided to test this law using the cosmic microwave background, CMB. This is the oldest light in the universe, the echo of the Big Bang, which fills all of space evenly. It is an ideal coordinate system, a kind of stationary background for the cosmos. And when scientists measured the temperature of this radiation, they saw a strange anomaly. On one side of the sky, the CMB was slightly warmer, and on the exact opposite side, slightly cooler. In physics, this is called dipole anisotropy, but in simple language it means the Doppler effect. We are moving. It turned out that our galaxy isn't just peacefully expanding along with space. We are rushing through space. And the speed of this movement is simply mind-boggling. 600 kilometers per second. Think about that. 2.2 million kilometers per hour. While you take a single breath, we travel 600 kilometers. By the time you finish watching this video, we will be more than 1 million kilometers away from where we started. Dark flow. But where are we flying? If this were random wandering, it wouldn't be so bad. But when astronomers began measuring the speeds of our neighbors, the Andromeda Galaxy, the Triangulum Galaxy, and dozens of other smaller satellites that make up our local group, their blood ran cold. All of us, our entire giant family of galaxies, are flying in the exact same direction. We are flying in a tight formation, ignoring the general expansion of the universe. This phenomenon has been named the dark flow. Imagine a river flowing north, but suddenly a powerful whirlpool appears in the middle, sucking the water east. The universe expands in all directions, but we are being sucked into a specific point in space located somewhere between the constellations of Centaurus and Hydra. The laws of physics are unforgiving here. To accelerate a behemoth like the local group of galaxies to a speed of 600 kilometers per second, a simply monstrous amount of gravity is required. Not a single star, not a single black hole, and not even a single galaxy is capable of this. To create such a pull, there must be something concentrated in that point of space possessing a mass of tens of thousands of trillions of solar masses. It must be something that warps space so severely that entire sections of the universe begin to drain into it like water down a bathtub drain. We know we are flying there. We know the speed. We know the approximate direction. But when we point our telescopes at that spot to look at our abductor, we see nothing. The zone of avoidance. It seems like some cruel, twisted joke of the universe, the greatest cosmic irony that the laws of physics are laughing at. Humanity has reached incredible heights in observational astronomy. We have built orbital telescopes capable of seeing the first stars born 13 billion years ago at the very edge of creation. We can examine microscopic dust specks and dried-up riverbeds on the surface of Mars. We peer into distances so unimaginable that the human brain cannot even properly comprehend them. But with all this technical power, we remain absolutely, hopelessly blind when it comes to what is happening right under our noses, in our own galactic backyard. Why don't we see this gravitational monster? Why does the Great Attractor remain invisible even though it controls the fate of our planet and the entire solar system? The answer lies in our extremely unfortunate cosmic address. We live inside the Milky Way. Our galaxy is not just a scattering of stars. It is a giant flat disk filled with billions of bright suns, clouds of scorching gas, and most importantly for us in this story, dense, impenetrable clouds of interstellar dust. To understand our situation, imagine you are sitting in the auditorium of a huge theater at the premiere of a breathtaking play. But your seat is not in the center of the stalls where the view is perfect, but at the very edge, behind a wide concrete pillar. You can see the stage perfectly to the left. You see the wings to the right. But what is happening right in the center of the stage, where the main action unfolds, is hidden from you by this cursed pillar. When we look at the night sky up or down relative to the plane of our galaxy's disk, the view remains clear and transparent. Before us opens deep, infinite space, full of distant galaxies. But the Great Attractor is located exactly within the plane of our galactic disk, right on the horizon line. This is the worst place for observation imaginable. When we try to point our optical telescopes in that direction, our gaze hits a solid, impenetrable wall. Billions of stars merge into a continuous blinding glow, and dark, cold dust clouds act like a thick curtain on a window. This cosmic dust ruthlessly absorbs visible light, preventing it from reaching us. We look point blank, but we see only dirt on our own windshield, behind which lies an abyss. Astronomers gave this cursed patch of sky a very disturbing and accurate name: the zone of avoidance. It sounds like a term from a sci-fi thriller or a horror movie, but it is a strict scientific fact. The zone of avoidance blocks about 20% of the entire sky from us. It is our giant blind spot, our Achilles heel. And by a monstrous, incredible coincidence, it is precisely there, in the very thick of this impenetrable darkness, that the object dragging us towards itself at breakneck speed is hiding. It is the perfect place for a cosmic ambush. If the Great Attractor were just a couple of degrees to the left or right, we would see it as the brightest, blinding spot in the night sky, outshining many stars. We would know our enemy by face. But it is hidden behind the dense veil of the Milky Way, and we can only feel its monstrous gravitational grip, but not see the object itself. This creates a sticky, unpleasant feeling of an invisible observer, a giant spider sitting in the dark corner of its web, silently pulling the strings, remaining in the shadows while its victim approaches. The search in the dark. For decades, scientists tried to break through this wall. They understood one simple thing. If visible light does not pass through the dust, then our ordinary eyes are useless here. We need to change the tool. Astronomers began scanning the zone of avoidance in other ranges, X-ray and infrared. These waves have a unique ability. They are much longer than light waves and are capable of bending around obstacles, seeping through the thick galactic fog, much like X-rays pass through the soft tissues of the human body to reveal bones. Armed with this new technology, scientists began to peer into the darkness, and gradually, pixel by pixel, the outlines of something truly grand began to emerge from the void, something that made astrophysicists hold their breath. The first and most obvious candidate for the role of the Great Attractor was a formation named the Norma Cluster. It is a massive, incredibly dense cluster of galaxies located relatively close to us, almost in the geometric center of the gravitational pull zone. When it was discovered, the astronomical community breathed a sigh of relief. It seemed the century-old riddle was finally solved. We found the culprit of our movement. We found the one pulling our strings. But when the euphoria passed and scientists began to scrupulously calculate the mass of this object, joy very quickly turned into deep disappointment and bewilderment. The Norma Cluster is indeed huge. Its mass is thousands of trillions of solar masses. This is a colossal figure for human perception, but mathematics is a stubborn, cold, and relentless thing. This mass is catastrophically insufficient. The gravity of the Norma Cluster is too weak to explain that insane, abnormal speed of 600 kilometers per second with which our entire local group of galaxies, including the Milky Way and Andromeda, is rushing through space. Attributing all this power to the Norma Cluster is like trying to explain the movement of a giant ocean liner by the thrust of a small boat motor. Yes, the Norma Cluster makes its contribution, it certainly pulls us, but it is only the tip of the iceberg, only a small, insignificant cog in a giant mechanism that we still do not see in its entirety. Scientists realized they needed to look further, deeper into the abyss, through even denser layers of dust and gas. And at a distance of 650 million light-years from us, far behind the Norma Cluster, they found a true Leviathan. This is the Shapley supercluster, the most massive gravitationally bound formation in our part of the universe known to us today. It is not just a cluster of galaxies, it is a cluster of clusters. It is a mega structure containing more than 8,000 galaxies, each of which can be larger than our Milky Way. Its mass is so great and monstrous that it bends the fabric of space-time for millions of light-years around itself, creating a gravitational funnel of incredible depth into which everything in existence slides. It would seem, here it is, the real Great Attractor. The Shapley supercluster is the strongest gravitational magnet we know. Its power is undeniable. But even here, after detailed calculations, a shocking surprise awaited us. Even if we add up the mass of the Norma cluster and the monstrous mass of the Shapley supercluster, even if we add to this the mass of all visible structures in that region, it is still not enough. The most accurate modern calculations show that these two giants together are responsible for only about 44% of our movement. Think about that. 44%. That's less than half. Where does the remaining 56% of the pull come from? What else is hiding there beyond the event horizon of our telescopes, even further into the depths of space? A frightening picture emerges. We see giants. We see colossal structures capable of swallowing worlds. But even their combined power is not enough to explain what is happening to us right now. This suggests a third, most terrible and uncomfortable version. Perhaps it's not just about hidden mass. Perhaps at such huge distances and scales, gravity does not work the way we are used to thinking. Maybe we have encountered a fundamental error in our understanding of physics, or there, in the very depths of the zone of avoidance, lies a structure whose dimensions simply do not fit into the human mind. Something so huge that the Shapley supercluster would seem like a grain of sand in comparison. We are chasing a ghost that gets bigger, scarier, and more massive as we approach it, and we still do not see its true face. Cosmic horror and the great void. But the scariest and most paradoxical discovery awaited astronomers quite recently in 2017. This discovery overturned our understanding of gravity and exactly how our galaxy moves. Up until this moment, we only thought about something pulling us. We looked for massive objects ahead on our course, trying to find that gravitational engine. But scientists forgot about the second, invisible part of the equation. Imagine a river. Water flows down not only because there is a lowland below where gravity pulls it, but also because pressure is created above at the source, pushing the water forward. The current is created by the difference in height. Well, our universe works in a similar way, only instead of height, here we have the density of matter. A team of researchers creating the most detailed 3D map of galaxy movements discovered something that made them shudder. It turned out that the Milky Way is not just passively falling into the pit of the Great Attractor. We are also being pushed from behind very hard with incredible power. Right behind us, in the diametrically opposite direction from the Great Attractor, lies a giant region of space almost completely devoid of matter. There are almost no galaxies, no stars, no gas. It is an absolute, ringing, dead, cosmic emptiness. Astronomers gave this region a name, the dipole repeller. It sounds paradoxical because a void cannot push. It weighs nothing, it has no energy. But in cosmology, a void works like effective anti-gravity. If on one side you have a super-dense cluster of matter pulling towards itself, and on the other, an absolute void where gravity is practically absent, then matter will flee from the void towards the density with double speed. It turns out we are clamped in a giant cosmic vice. On one side, we are greedily sucked in by the invisible vacuum cleaner of the Great Attractor, and on the other side, we are aggressively pushed out by the icy breath of the Great Void. We are not just flying, we are literally being thrown through space. It was at this moment that we realized our true, frightening scale. For a long time, we thought our home was the Virgo cluster, a small, cozy group of galaxies. But new data allowed us to see the whole picture, and it staggers the imagination with its grandeur. We are just a tiny part of a gigantic, unimaginably huge structure named Laniakea. Translated from Hawaiian, this beautiful word means immeasurable heavens. And this name fits perfectly. Laniakea is a supercluster of galaxies that spans 520 million light-years across. It contains more than 100,000 galaxies, each full of billions of stars. If you look at a map of the universe, Laniakea looks not like a ball or a disk. It looks like giant glowing fibers, like neuron threads in the brain of a titan, or the root system of a colossal tree piercing the void. And all these threads, all these 100,000 galaxies, including our tiny Milky Way and our solar system, are slowly but surely flowing into one point. We are all just drops in a giant waterfall. We are sliding along the gravitational veins of the universe, straight into the heart of the Great Attractor. This realization evokes a feeling of true cosmic horror. We are not independent. We are not standing still. We are just a grain of sand carried by a turbulent, inexorable current, and we are powerless to resist this flow. Our entire history, all our civilizations, it is just a moment in an endless fall towards the center of a gravitational web. How will it all end? Now that we know exactly where we are flying and at what monstrous speed we are being dragged there, the most important, most frightening, and natural question arises. What will happen when we finally get there? Will it be a giant cosmic catastrophe? Will we crash into a wall of millions of other galaxies that arrived there before us? Will our star system perish in the fire of an incredible gravitational collapse when matter compresses into a point? The answer to this question is simultaneously soothing and driving into deep existential depression. The greatest paradox of our universe is that we will never reach the destination. It is a race that cannot be won, a marathon without a finish line. The fact is that right now in the universe, there is a constant titanic struggle between two fundamental forces. On one side acts gravity, which tries to gather all galaxies into one pile to tighten Laniakea into a tight knot at the point of the Great Attractor. On the other side acts dark energy, a mysterious, invisible force, the nature of which is unknown to us, but which forces space itself to expand faster and faster, pushing objects away from each other. Yes, the Great Attractor is pulling us towards itself at a speed of 600 kilometers per second. This is incredibly fast by Earth standards, but the space between us and the attractor is not standing still. It is expanding, and the more time passes, the faster this expansion happens. At some point, according to Hubble's law, the speed of the expansion of space between us will exceed our own flight speed. The Great Attractor, this gravitational monster, will start moving away from us faster than we can approach it. We are like a runner on a treadmill who is trying with all his might to catch up to the horizon, but the track moves backward faster than he is capable of running forward. In the distant future, billions of years from now, dark energy will finally defeat gravity. It will tear the magnificent structure of Laniakea apart. The gravitational bonds between galaxy clusters will break. The Great Attractor, remaining an unsolved mystery, will go beyond the cosmological event horizon. It will simply disappear from our field of view forever, as light from it will no longer be able to reach us. We will remain alone in the expanding cold void, isolated on our small island of a few neighboring galaxies, never knowing what it was. This is perhaps the saddest and most philosophical finale for astronomy's greatest mystery. We are flying into nowhere, into a giant gravitational grave that we will never see and never reach. The Great Attractor will forever remain a ghost that beckoned us across the entire universe, controlled our movement, but never allowed us to touch it. If you enjoyed this journey into the darkest and most frightening corners of space and want to see more stories about the mysteries of the universe, just like this video and subscribe to the channel. It really helps us search for new riddles. Thank you for being with us.